Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the reactive power compensation and their types. So, just as an overview, uh, normally the reactive power in the sense the apparent power which drives the active power. So, it is mainly useful for driving the active power in our power system. So, it is further divided into a capacitance and inductive type of reactive powers. In here we are commonly going to see about the types of your reactive power compensation as a single type compensation, then bulk reactive power compensation, and central reactive power compensation. First one is the single type compensation. This is mostly used in your home appliances and in your inductive loads, which consumes more than 50 to 70% of your rated power. So this type of single type compensation is mainly serves the separate contactor for the capacitor, then full or partial discharge of your feed in lines by reactive power, then reduce the active power loss in your transmission. Next, it is mainly used at a load with a steady state of your compensation. Then each consumer is connected to the capacitor determined by its demand of reactive power, which means it is connected by a defined number of capacitors. Then it reduces the transmission long losses along with the cable. Then it is mainly used in your asynchronous motors, then self-exciting motors, then star delta connections of your motor, then for your compensation of your transformers like welding transformers, which is commonly used. Then single type compensation in your motor. So the determination of your capacitor size should be 90% of a reactive power demand in a no load in order to avoid the over excitation and voltage peaks, which means if we designed or used the capacitance over the level of your reactive power means automatically leads to over excitation and voltage peaks. And its finding formula is that for finding the reactive capacitance, it's 90% of your reactive power, which means zero point 0.9 into root 3 your into I naught, which means your ideal current and your voltage. Then we can connect capacitor directly to the motor terminal or via separate contactors. So this is the connection of your squirrel cage motor in which the reactive power compensation connections has been done. So in here the motor circuit which is connected with the line, and parallelly one reactive power compensation capacitance has been connected. Then this is the connections of your star delta connections. So in here we have a special contactors for the capacitors. Here we have a K1 for grid capacitor, K2 for delta connectors, then for your K3 star contactors, then for your K4 contactor for your capacitors. So we have four contactors. Each contactors will get picked up and functions according to their level need of operation. Then this is the capacitor rating needed as per your motor rated power. So in most of 1 kilowatt to 3.9 kilowatt, we will use a 55% of your motor rated power as a kVR. Then for 4 to 4.9 we have 2 kVRs, then 5.5 to 5.9 2.5 kVRs. Likewise, for each motor rating, we will increase the kVR rating also. Next is your single type compensation of your transformer. So the total reactive power, which means the QT is composed of two components. One is your reactive power during open circuit and the reactive power caused by your leakage field at a short circuit. So the Q2 is equal to Q0 or Q0 plus UK divided by 100 into S divided by SR, the both are in square, then into SR. So in here SR in the sense transformers rated power, then S is your load, UK is your impedance, transformer impedance voltage. So this is the total reactive power findings for your transformer. Then if we connect excess of capacitor for a reactive power, then it causes a overcompensation during a low load period, which means automatically your secondary voltage get increased more than the level what the load needs. So secondly, we need to pay attention for the resonance occurring between the transformer and the capacitors. This could occur due to the existing harmonics like 5th, 7th, 11th and 13th harmonics, which and all exist during the normal connections of your transformer to the load. So we have a formula for finding the resonance frequency. The resonance frequency is equal to Fr into root of SR into 100 divided by N square into UK. Here the Fr is your fundamental frequency, then SR is your transformer rated power, QC is your capacitive reactive power, UK is your impedance voltage, and N is your harmonics order. Then the maximum of your capacitor permissible reactive power is QC is lesser than or equal to SR into 100 divided by N square into UK. Example, if a transformer which is having a nameplate of 630 kVA and the impedance voltage is 6%, we need to find the maximum reactive power of the capacitor in order to avoid a danger of a resonance up to a 13th harmonics. As you know, the formula is your total kVA, which means your kVA into 100 divided by the uh, nth harmonics into square of the nth harmonics into a impedance voltage. So in here already we have known the values, so we have just implementing the values as given in your example, and we have found the total reactive power capacitor is approximately 62 kVAr. So this is the connection of your power transformer with a parallel connection of your fixed compensation as required for your system. So in here the Q in the sense the breaker, F is your fuse, LV side and the HV sides are mentioned in your transformer, and the parallel connection of your capacitors has been given. With that example, we can able to find the total capacitance of your reactive power also. Next, coming up to the single type compensation of your fluorescent lamps. So these are having a non-linear characteristics with a time course of voltage and current. In order to limit the current, the inductance and the leakage field of your transformers are connected in a series or a parallel conditions. Then the determination of your capacitor depends on the current limiter, which means your inductors, power of your lamp and the capacity. Next, modern lamp includes electronics device to limit the current, so there is no need of your capacitor compensations. Hence, the power factor of your modern lamps will be almost unity. Then, most economical method is duo circuit, which means double circuit connecting with one another. Uh, this method includes one capacitor for two lightings. So as two lights have a two different current limiting devices, one with the standard inductor and other with a series combination of your capacitor and the inductors. Let's see one example of your fluorescent type of connections. Uh, in this diagram A and B, we have a compensation of a single tube and compensating of a two tubes, which means two lamps. In here, the E in the sense your tandem or two tubes connections, uh, tubes. Then the L is your current limiting reactors, and C is your compensation capacitor. G is your corona injector. As I said, the first diagram is for your single type or a single tube compensation. In here where we have a capacitors connected in parallel, and second one is for your dual type or a duo circuit combinations. The same set what the single type is used, but that is replicated for the two types. So this is your duo circuit diagram. In here we have a one single inductors connected in one end, and another with the series connection we have a another set of inductor and with the combination of your capacitors. So this is will forms a duo circuit for your lamps. Next is your bulk type compensations. So this is mostly used by the inductive consumers connected in a parallel operation. The following need to be considered for using a bulk type as a capacitor causing a high inrush current. If the instantaneous voltage is oscillating, then separate contactor will be fitted for switching operations of your reactive power. Then the reactive power of the capacitor must not exceed the sum of the reactive power in the low load operations. So these are all the consideration of your bulk type compensation. So bulk type in the sense, uh, in factories and in industries we have a numerous number of synchronous machines or asynchronous machines. So in order to maintain a proper active power level, we need a same kind of a reactive power for your transmission. So we are using or we are going with the bulk type of your compensation. This is the best example of your bulk type compensations where all the motors are connected with a common capacitor banks and your reactive power or compensation. Next is your central type compensation. In a large electrical plant with a high fluctuation of load, this type is automatically controlled by a power factor relay. So the main advantage is that the improvement in a voltage stability, then the reactive power of the capacitor bank is adapted to demand, then uh, controlled compensation, which means automatically we can compensate with a controlled level of your compensation. That too has been carried along with the power factor relays, then optimize the utilization of your capacitors. So automatically we can avoid the over excitation and higher level of voltage whenever there is no load or a very low load condition. So this is the example of your central type compensation. In here we are using one power factor relay for the regulation of your or automatic regulation of your compensation, which means your reactive power. So the reactive power will be connected according to the level or according to the number of motors or number of machines connected with the load. That's why it is known as the automatic regulation of your compensation or a reactive power compensation. Then this is the mixed compensation of a system. So in here we have all mixed, all compensation mixed with one another. So we in this we have a single type compensation, then central type compensation, bulk type compensation, then single type for the motors and for your transformers and for your illuminations, which means your fluorescent lamps, fluorescent, hydrogen, helium, sodium vapor type of lamps. Just you can go through it. Hope you understand. I think so. These are all the basic common types of your reactive power compensations. See you in next video. Have a nice day. Nandri. Vanakkam.